This is SpaceTime Series 27, Episode 143, for broadcast on the 27th of November 2024. Coming up on SpaceTime, a new study shows that our Milky Way galaxy isn't typical, getting ready for liftoff on Europe's Probe 3 mission to study the Sun's corona. And you probably haven't heard about it, but a secret Australian military satellite has just been launched. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
A new study surveying our part of the universe has discovered that our Milky Way galaxy isn't typical, but rather an outlier among similar galaxies. The findings, reported in the Astrophysical Journal, is based on 3 new studies which are raising serious questions about whether the Milky Way is truly representative of other galaxies in the universe. One of the study's authors, Risa Vessler from Stanford University, says that for decades now, scientists have been using the Milky Way as the model for understanding how galaxies form and evolve. And the Milky Way's been an incredible laboratory, including for the physics of galaxy formation and the physics of dark matter. But for a long time, astronomers have understood that the Milky Way is only one system, and it may not be typical of how other galaxies are formed. That's why it's crucial to find other similar galaxies and then compare them. So to achieve that goal, Vessler co-founded the Satellite Surround Galactic Analogues, or SEGA survey, dedicated to comparing galaxies similar in mass to our Milky Way. After more than a decade of scanning, the SEGA team identified and studied 101 Milky Way-like analogues as a first step in its ongoing research. The results reveal that in many ways, the evolutionary history of the Milky Way is different from other comparable-sized galaxies. See, our Milky Way is made of ordinary atomic matter, like hydrogen, helium, iron, and other elements in the periodic table. But of course the thing is, ordinary matter, what we call baryonic matter, only accounts for about 15% of all the matter in the universe. The remaining 85% is a mysterious invisible substance we call dark matter. Dark because we have no idea what it is. No one knows what dark matter is made of because it simply doesn't interact with ordinary matter or energy. But we know it exists because we can see its gravitational interaction with normal matter. The current hypothesis suggests that galaxies tend to form inside massive regions of dark matter known as dark matter halos. A dark matter halo may be invisible, but its enormous size creates a gravitational force strong enough to pull in ordinary matter from the surrounding space and then transform it into stars and galaxies. So a key objective of the SEGA survey has been to determine how dark matter halos impact galactic evolution. To begin, the SEGA team focused on galactic satellites, smaller dwarf galaxies that orbit much larger host galaxies like the Milky Way. The authors looked at 4 of the Milky Way's brightest satellite galaxies, including the 2 biggest, known as the Large and Small Magellanic Clouds. They then undertook a painstaking search for satellite galaxies around other host galaxies of similar mass to the Milky Way. Eventually, they identified 378 satellite dwarf galaxies surrounding the 101 Milky Way-like hosts. The authors eventually found that the number of satellites per host galaxy ranges from 0 to 13. And of course the Milky Way's 4 observable satellites fit well within that range. But the study also revealed that host galaxies with large satellites similar in size to the Milky Way's Large and Small Magellanic Clouds tend to have more satellites overall. So the Milky Way actually hosts fewer satellite dwarfs than similar galaxies, and that makes it an outlier among its peers. Now, a second study focused on star formation within these satellite galaxies, an important metric for understanding how galaxies evolve. The study found that in a typical host galaxy, smaller satellite galaxies are still vigorously forming stars. The problem is, in the Milky Way, star formation really only occurs in the Large and Small Magellanic Clouds. All the other smaller galaxies orbiting the Milky Way stopped forming stars long ago. And that raises an interesting question. What is it about the Milky Way that caused all these other small low-mass satellite galaxies to quench their star formation? Maybe, unlike a typical host galaxy, the Milky Way has a unique combination of older satellite galaxies that have already ceased their star formation. And newer active ones, like the Large and Small Magellanic Clouds, are only recent additions that fell into the Milky Way's dark matter halo. The study also found that star formation typically stops in satellite galaxies located closer to the host galaxy, perhaps because of the gravitational pull of dark matter halos in and around that host galaxy. And of course there are lots of other questions, such as the location of the Milky Way within our galaxy cluster, the distance of the Milky Way galaxy from the nearest large void, and the position of the Milky Way galaxy and its galaxy cluster within the larger cosmic web of the universe. This is SpaceTime. Still to come, Europe's Probe 3 spacecraft ready for launch to study the Sun's corona. And you may not have heard about it, but Australia's just had a secret military satellite launched. All that and more still to come on SpaceTime. Well, all systems are now go for next month's launch of the European Space Agency's new Probe 3 mission to study the Sun. The double satellite is the most ambitious member yet of ESA's Probe family of experimental missions. It consists of two spacecraft, known simply as CSC and OSC. They'll fly together as one unit, maintaining precise formation right down to the millimetre. One of the spacecraft will block out the fiery disk of the Sun for the other, in order to enable prolonged observations of the Sun's surrounding atmosphere, the corona, which is the source of the solar wind and space weather. Usually, the corona can only be glimpsed for a few minutes during terrestrial total solar eclipses. So, Probe 3 aims to reproduce such eclipses for up to 6 hours at a time, by flying in a highly elliptical orbit, taking it more than 60,500 kilometres above the Earth. The CSC is a 300-kilogram mini-satellite hosting the chronograph and the shadow position sensors. It's equipped with a monopropellant propulsion system in order to perform large delta-V maneuvers necessary for formation acquisition and braking. It also hosts the targets used by the metrology optical heads on the board of its sister spacecraft, the OSC. The OSC itself is a 250-kilogram mini-satellite hosting the laser and visual metrology optical heads. It features a 1.4 metre diameter optical disc. The shape of its rim is intended to reduce the amount of sun-diffracted light entering the chronograph. The OSC uses a low-thrust cold gas propulsion system that will enable the fine position control required for formation flying. The primary payload is, of course, the chronograph itself. It follows the design concept of a classical externally occulted Lyot chronograph, with the external occulter physically attached to the OSC, while the rest of the instrument package is on the CSC. The chronograph will observe the solar corona through refractive optics, able to select 3 different spectral bands. A second scientific payload hosted on the OSC is the Davos Absolute Radiometer, which will measure total solar irradiance. The two spacecraft are being launched together by ISRO, the Indian Space Research Organisation, aboard one of its PSLV-XL launch vehicles from the Satish Dhawan Space Centre on December the 4th. This report from ESA TV.
Probe, from the Latin for let's try, is ESA's family of experimental small satellites. Over the last 2 decades, Probe missions have pushed forward spaceflight technology while gathering valuable science data. The next in the series, Probe 3, is the most ambitious yet. 2 satellites will fly together as one with millimetre-level control of their positions within a precise formation. In the process, one will eclipse or block the Sun for the other, to reveal our star's faint surrounding coronal atmosphere for scientific observation. Liftoff will take place where the Probe story began, India's Satish Dhawan Space Centre, site of Probe 1's launch in 2001. Probe 3 requires a unique orbit, making the powerful PSLV-XL launcher, developed by the Indian Space Research Organisation, the perfect choice for launch. With Probe 3 as its sole passenger, the launch vehicle can perform a tailored orbit insertion, setting the mission on course. The 2 Probe 3 satellites will travel to space stacked together. Topmost is the occulter spacecraft with its 1.4 metre diameter occulting disk, which will observe the Sun in eclipse. The satellite's orbit is highly elliptical, taking them to a maximum of 60,000 kilometers from Earth. Gravitational, magnetic and atmospheric perturbations are much lower this far out. This will make possible the precise positioning needed for formation flying and observing the Sun's corona. Once separated from their launcher, the conjoined satellites need to come to life. The spacecraft will orient their respective solar panels to the Sun to acquire a sufficient power to wake up onboard systems and allow commissioning to begin. Only once their joint commissioning is complete will the spacecraft be separated. Then they will begin their individual commissioning and enter their initial formation. At this stage, it is important that the Probe 3 satellites perform a series of maneuvers to position themselves in relatively safe orbits with respective to each other. Achieving this nullifies any risk of the pair either drifting away from each other or colliding. After all commissioning checks are complete, the pair will be ready for their first flight in precise formation. The separation between spacecraft will be as short as 25 meters and as long as 250 meters, with a nominal separation of around 150 meters. The pair will determine their relative positions using a suite of metrologies, including radio links, satellite navigation, and the visual-based system with optical tracking of blinking lights. Once sufficient accuracy has been achieved, the final step will be to deploy the most precise measuring system of all, the laser metrology system, known as the fine lateral and longitudinal sensor. With this laser link, the total three-dimensional formation can attain millimetre level control. At this point, the occulter, lined up with the Sun, will cast a perfect shadow for sustained observation of the Sun's otherwise invisible corona. Once the occulter's shadow is maintained in just the right spot on the face of the other satellite, it will be safe for the coronagraph to open its protective door and start scientific observations of the Sun's corona. Solar scientists travel the world to glimpse brief solar eclipses, but Probe 3 will create eclipses on demand.
This is SpaceTime. Still to come, you may not have heard about it, but Australia has just had a secret military satellite launched. We'll have all the details shortly. And later in the science report, a new study has shown something most people already know. House cats can associate human words with images without any prompting or rewards. All that and more still to come on SpaceTime. SpaceX has just launched a classified mission for Optus and the Australian Defence Force. The flight aboard a Falcon 9 rocket from Space Launch Complex 39A at the Kennedy Space Center in Florida placed the so-called Optus X payload into a geostationary orbit at an altitude of 36,000 kilometers. Now, SpaceX haven't released any details of the mission, which is simply known as TD-7. But it appears to be a classified military telecommunications satellite built by Northrop Grumman Innovation Systems subsidiary Space Logistics. The new robotic-capable spacecraft is designed to allow a mission extension pod to be docked to it in the future. We think Optus X was built on a Geostar 3 bus. Now, the X could refer to a military X-band payload, similar to that which was previously employed by Optus on its 2003 dual-use C1 satellite. You may recall we covered that spacecraft at the time on Star Stuff. It was partially funded by the ADF and included dual military and civilian payloads on the one platform. Optus were pretty open about that launch, so why they're being so secretive this time round is hard to fathom. The ADF's military satellite communications, or MILSATCOM, includes space, ground and control segment assets. Its various systems are operated through a special agreement with industry partners such as Optus and the US government. We know that the Optus satellite was the only payload on board the flight. That suggests it was close to the Falcon 9's launch capacity. The flight was the 16th launch for the same first-stage booster, which then successfully returned to Earth, landing on the drone ship a short of gravitas, which had been pre-positioned downrange in the North Atlantic Ocean. Space Logistics say its mission extension robot servicing spacecraft should be ready to fly next year. It'll provide a significant advantage to orbiting satellites by extending their lives by adding a customer-controlled propulsion augmentation extension pod to the spacecraft while in orbit. This is SpaceTime. And time now to take another brief look at some of the other stories making news in science this week with the Science Report. The World Health Organization is warning that measles cases have now surged across the world, with an estimated 10.3 million cases last year. That's a 20% increase over 2022. The WHO's Morbidity and Mortality Weekly Report found a lack of immunization coverage was the driving force for the surge in cases. As a result of global gaps in vaccination coverage, 57 countries experienced large or disruptive measles outbreaks in 2023, affecting all regions, including the Western Pacific, which experienced a substantial upsurge in cases. A new study has found that a large ice field in Alaska has been losing ice at an accelerated rate since 2005, compared to its average ice loss rate over the past 250 years. The findings, reported in the journal Nature, are based on detailed historical records, aerial photographs, 3D terrain maps, and satellite imagery designed to determine the ice field's behaviour over the past 2.5 centuries. Scientists found that between 1770 and 1970, the glacier started losing approximately 0.65 cubic kilometres per year. That increased to approximately 3 cubic kilometres annually between 1970 and 2010, and then it nearly doubled to 5.9 cubic kilometres per year between 2010 and 2020. As Alaskan glaciers are especially vulnerable to climate change, the authors say that these ice fields will become one of the largest contributors to sea level rise. Well, if you have a family cat living at your place, you already know this. But scientists in Japan have shown that domestic house cats are capable of associating human words with images without any prompting or reward. The findings, published in the journal Scientific Reports, are based on tests in which cats looked at images on the computer screen to see if they formed associations between images and spoken words. Now, previous research has already shown that cats know their names and they know numerous keywords and phrases. Other experiments have also shown that cats can match photos of people they know to their names. But this new research confirms that cats actually understand many of the words spoken to them. So, to find out if cats have the ability to match a word with an object, the authors enlisted 31 volunteer adult house cats. Each was given a word test, originally designed to learn more about word association in growing human infants, and these involved being shown short animations. While the images were being displayed, a nonsensical word was broadcast. Each cat saw 2 such animations. The videos were played on a continuous loop until the cats looked away. After giving each cat a break, they were each once again placed in front of the computer screen, and the same 2 animations were shown on a loop. But this time, the spoken words were reversed. As the cats watched the videos, the researchers watched the cats. They found that they stared longer when hearing the word than during the original broadcast. Some even showed pupil dilation. Now, both of these are signs that the cats were confused by the switch-up and were looking intently to find an explanation. Evidence that they had associated the words with the images on the computer screen, even in the absence of a reward. The findings indicate that cats commonly associate words they hear from humans with objects in their environment. Internet security company Norton's have just issued a new cyber warning. With the details, we're joined by technology editor Alex Zaharov-Reutt from TechAdvice.life.
Their parent company is Gen, and they've just released their latest report showing that in July through September, scams are continuing to dominate the threat landscape. And what they've seen is a 614% rise in scam yourself attacks. This is where cybercriminals are using social engineering and psychological manipulation tactics to get you to infect your own computer with malware. And they do this by fake tutorials, where you have these tutorials tutorials on YouTube to lure you into installing malware while pretending to provide free download for paid software. So if you're looking for pirate software, I mean, that's long been a way to get attacked. You have these click fix scams. This is under the guise of fixing a computer issue. You've got this fake technical solution which prompts you to copy some text into the command prompt, which then gives cyber criminals control of your system. Fake captures. This is where you get those little funny letters and numbers with wavy lines, and it copies the text of dangerous code onto your clipboard and instructs you to install this malicious content onto your device. Even fake updates, which we've seen for a long time with the old fake updates to Adobe Flash, for example, but they're still around. This is disguised as a necessary software update to guide you to paste a malicious script into your system, giving attackers admin privileges. And we just on this whole thing, we just had updates last week for all the latest iPhones and Apple Watches and Macs, and they close, as usual, a whole bunch of security holes, and sometimes the latest attacks are based on security vulnerabilities that have been fixed, but people haven't updated their systems yet. So even though you might think, oh, I'm not going to get caught by this, if you've got some problem and you try and fix it yourself, then you can end up giving the bad guys keys to the kingdoms. Ransomware threats also increase massively, and that's another big issue. You've got to have some sort of protective software on your device, especially if you're using it for business, and of course, making backups of everything. If you do get infected, it's much less of a problem. I mean, it's still a hassle to restore everything, but if you have backups in multiple locations, then if you do get caught by one of these things, at least you can restore.
And the other big story has to be ChatGPT wanting to develop their own browser.
Yeah, well, this is hot on the heels of the Department of Justice in the US asking Google to consider breaking up with Chrome. So Chrome, of course, is Google's big browser. Now, OpenAI is the AI company that's basically become a search engine. They've got their Search GPT, which gives results. And we also have things like Perplexity, and we have Microsoft, who also owns a browser. OpenAI has been talking to website and app developers about whether or not there's any appetite for an open AI browser. And this would presumably be running on Chrome, or Chromium, the open source version of Chrome, just like Microsoft has done with Edge, because you've got compatibility with all of those Google and Edge extensions that are out there, which makes the browser more useful in different ways. Now, there's no time frame. I mean, we don't know if they're going to do this, but they have been thinking about it. But again, if you've got the DOJ wanting to split Chrome away from Google, they've tried to do that with Microsoft Internet Explorer back in the day, and that didn't work either. So never-ending advances, but also threats of government interference in the world of tech.
Now, speaking of government interference, it looks like the Internet Censorship Bill will be defeated in the Senate. I'm sorry, it's the Misinformation and Disinformation Bill, isn't it?
Yes.
It's all about Internet censorship, let's face it. But there's still the other half of the monster that's yet to be defeated, and that is preventing kids from having access to social media. There are a lot of good reasons why social media should be restricted for kids, but it's also a gateway for the Albanese Labor government in Australia to force people to use digital ID.
Yeah, look, this is the Trojan horse under the guise of won't somebody save the children. I mean, look, during the pandemic, we had the government force every child to go online to do their schooling and to learn things and, to use all the different platforms. And now all of a sudden they want to block kids.
This is the same government who told us not to let the kids go out into the playground where the fresh air is and where it's less likely that they'll get COVID. And kids don't get COVID very easily anyway.
Yeah, and certainly if they do, they heal a lot faster. Look, the short version is that the government wants control. I mean, which government doesn't want control? We know that there's a deep state in most Western countries, and certainly in non-Western countries. I mean, the deep state is there.
By introducing a digital ID, it means the government can track everything you do and everything you watch.
That's exactly right. The government wants to be able to know what its citizens are doing at all times, and frankly, it's none of their business. I mean, we cannot be the generation that let privacy slip through our fingers.
That's Alex Zaharov-Reutt from TechAdvice.life. That's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies. Or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.